Hello, everyone, and welcome back to The Explainer. An asthma attack can be a really scary thing, that sudden, desperate fight for every single breath. But what's actually going on inside our lungs to cause it? Well, today, we're going to pull back the curtain and look at the science behind it all, from the first trigger to the medicines that help us breathe easy again. So let's start with the big question. When someone has an asthma attack and they're struggling to breathe, what is really happening on a microscopic level? What flips the switch inside our airways to cause such a dramatic and sudden change? That's the mystery we're going to solve today. All right, so to understand an attack, we first have to get a handle on what asthma actually is. There are three key words here. First, it's chronic, which means it's a long-term thing you manage, not something that just goes away. Second, it's all about inflammation. That's the real root of the problem. And third, and this is really important, it's reversible. Now, that doesn't mean it's cured, but it does mean we can reverse the symptoms of an attack with the right treatment. Okay, look at this. The difference is just night and day, right? On one side, you have a healthy airway. It's like a big, wide open pipe. Air just flows right through, no problem. But in an asthmatic airway during an attack, it's like a triple threat. The walls of that pipe get inflamed and swollen, the muscles around it squeeze tight, and your body produces way too much thick mucus. It's basically the perfect storm for choking off your air supply. And this right here explains exactly how an attack feels. That high-pitched wheezing sound, that's literally the sound of air trying to force its way through those tiny, narrowed passages. That feeling of tightness in your chest, that's those muscles squeezing down. And of course, the shortness of breath, the coughing, the fatigue, that's all your body desperately fighting for more oxygen. So, what on earth causes such an intense reaction? Well, and this is the fascinating part. It's not actually a problem with the lungs themselves. It's your body's own immune system going into complete overreaction mode. So, let's break down this chain reaction step by step. It all kicks off with a trigger. For a lot of people, this is something that's totally harmless, like pollen or dust mites or pet dander. But for some reason, the immune system gets its wires crossed. It sees this harmless substance, which scientists call an antigen, and mistakes it for a dangerous invader. It sounds the alarm. The first responders on the scene are these cells called macrophages. You can think of them as the security guards patrolling your body. They see this invader, they gobble it up, and they immediately send out an emergency signal to a more specialized team called T helper cells. They're calling for backup. Now, the T helper cells, they're like the generals of this immune army. They get the signal from the security guards and they give the order to another group of cells, the plasma B cells, to start building weapons. And these aren't just any weapons. They are custom-built, heat-seeking missiles called IgE antibodies, and they are designed to hunt for that one specific allergen and nothing else. So here's the thing. This first time you encounter the pollen or dust, it doesn't actually cause an asthma attack. Nope, this is all just prep work. These new Ig antibody missiles travel through your body and latch onto the outside of another type of cell called mast cells, which are hanging out all over your airways. They're basically setting a trap, arming these mast cells, and just waiting for that invader to show its face again. And then it happens. The next time that same little piece of pollen or dust gets into your body, the trap is sprung. The allergen connects directly with those IgE antibodies that are just waiting on the mast cells, and that simple connection is the trigger. It causes the mast cells to instantly rupture, to just burst wide open. The scientific name for it is degranulation. And when those mast cells burst, they release a chemical flood into your airways, all sorts of stuff, but especially chemicals like histamine and leukotrienes. And these chemicals are what cause all the chaos. They're the signals that tell the airway walls to swell up, the muscles to squeeze tight, and the mucus glands to work overtime. This, right here, is the asthma attack. So at the end of the day, after that whole complex immune system cascade, it all boils down to this one simple, dangerous reality. The path for air becomes so narrow that it just can't pass through properly. But, and this is the really good news, because we understand this entire process in such incredible detail, we've come up with some seriously clever ways to step in and stop it. So how does the science of relief actually work? Let's take a look. Modern asthma treatments basically fall into four main game plans, and each one targets a different part of the problem we just talked about. You've got the rescuers for fast relief, the peacemakers to calm things down, the guards, which stop the whole process from kicking off, and the interceptors, which disarm the system before it's even ready to fire. Now, it's so important to get the difference between the two most common types. Rescuers, your blue inhaler, They're like the firefighters. They rush in to deal with the emergency after it's started. They work in minutes to relax those squeezed muscles around the airway to pry it back open. Peacemakers, on the other hand, are like the fire marshals. They're for long-term control. They work slowly to reduce the swelling and inflammation of the airway wall itself. One is an emergency fix, the other is daily prevention. Okay, remember step 5? That critical moment when the mast cells burst open? Well, this type of drug, the mast cell stabilizers, works directly on that step. They act like guards, reinforcing the outer wall of the mast cell. So even when the allergen shows up and tries to trigger it, the mast cell is strong enough to hold itself together, stopping that flood of inflammatory chemicals before it even starts. And this is one of the most advanced strategies we have. This medication is a true interceptor. It basically rewinds the whole process. It finds those IgE missiles we talked about from step 3 while they're just floating around in your system, and it neutralizes them before they ever have a chance to attach to the mast cells in step 4. It's like disarming the trap before it's even fully set. Pretty brilliant, right? So while we don't have a cure for asthma just yet, our deep understanding of what's going on means we can control it incredibly well. And that brings us to the final piece of the puzzle, what this looks like day to day as a lifelong journey of management. Really, managing asthma well boils down to a few key things. You've got to know your personal triggers and do your best to avoid them. You have to use your medications exactly like your doctor says, especially knowing the difference between your rescuer and your controller. And you need to work with your doctor to have a clear action plan, all of which is supported by just living a healthy lifestyle. And that's really the big takeaway here. This isn't something that just comes and goes. It's a chronic condition that needs consistent, thoughtful management. But with the right knowledge and the right tools, people with asthma can and do lead totally full and active lives. And that leaves us with a pretty cool question to think about. I mean, we've gone from just physically opening the airways to literally intercepting specific molecules in the immune system. So as our understanding gets even deeper, what's next? What might the next generation of asthma treatments look like? It's exciting to think about.